So this was similar to a problem that we did in class. If we let u equal e to the x over 6 plus 1, there's only a couple choices for u. One would be let u equal x over 6, but that won't get us anywhere. We'll get back to the original problem, except it's written in terms of u, which really doesn't help us. But if we let u equal e to the x plus 6 plus 1 and take the derivative of this, we get e to the x over 6 times the chain rule, which is the derivative of x over 6. And then the derivative of 1 is 0. So we're left with 1/6 e to the x over 6. Right? That is your derivative of u. So if we solve for dx here, we get dx, right, is equal to 6 du over x over, e to the x over 6. So let's make the substitution. I'm going to come up over here so we can continue this. Minus 6 to the 6th, and e to the x over 6 is not anything that we can substitute for. U is equal to the denominator, and then dx is equal to 6 du over e to the x over 6. So algebraically these will cancel out, and we're left with the integral. I'm going to pull the 6 out of du over u, which is simply 6 ln of u. So I'm going to, we can do one of two things at this point. It's a definite integral. We can change the limits in terms of u, and I think I'll do that in this case. Let's do that. So this is 6 times, you put negative 6 into u, so this is e to the negative 6 over 6 plus 1, and up top you get e to the 6 over 6 plus 1, and oops, that would have been du over u. I'm sorry, I should have just, okay, so this is going to be evaluated at e to the first power is just e, so this is evaluated e plus 1, and down below we've got a minus 1, so this is going to be e to the minus 1 plus 1. So let's substitute in these limits. I'm going to scroll down and continue. I'm going to continue over here now. Sorry about this little bit of a mess, but I knew the algebra and I didn't want to run out of space, writing space. So you've got 6 ln of e plus 1. This is a tricky problem in the algebra, and if you've forgotten some of the algebra of logs, it might have caused a problem for you. So minus 6 ln of 1 over e plus 1. Right, all I did here was substitute in the upper limit of integration and then the lower limit of integration. So now what I'm going to do is actually a little bit of algebra, a little bit of log algebra. I'm going to do some combining. So I'm going to keep that 6 outside for a minute. I'm going to combine these terms. If you recall, with log functions, you can write them as single expressions. So if you want to take logs that are added, subtract it, and you want to write it in a single expression, you can by combining. So addition maps to multiplication and subtraction maps to division. So this is subtraction between these two logs. So I'm going to combine them, and I'm going to leave it highlighted like that, okay, because that's the equivalent. Remember that ln of x minus ln of y is equal to ln of x over y. These are log properties. This is not calculus, this is algebra, okay? So, doesn't matter which calculus class you're in, you'd be dealing with this algebra piece. And what you need to do here is combine these terms under, combine the denominator under a like, oops, under a like common denominator. So I'm going to rewrite this bottom as 1 over e1 plus e, and this is e plus 1, which is the same thing. And you're left with 6 times, well, ln of 1 plus e over 1 plus e, these are going to cross out, and you're left with ln of e. And ln of e is just 1. So the answer here is 6. And I'm going to check it to make sure, and that is the answer. So I hope this video helps. I'm going to post it for the entire class.